Hello everyone, welcome to episode 31 of Reconstructing Cave Story. In this episode we're going to be looking at implementing our gun bob, which is just a small up and down movement of about a pixel of our gun while we are walking. And at the same time we're going to fix our walk because our walk is a little bit off. So what's wrong with our walk first of all? Well, we start off at the middle of our stride. We can call this first frame our mid stride. And then we have our left stride over here and then our right stride. So we end up looping through middle, left, right, middle, left, right, middle, left, right. And that's our walk animation. But what it should really do is oscillate between left, middle, and right. So it should go left, middle, right, middle, left. So let me show you. Excuse me. Let me show you. It should be left, middle, right, middle, left, middle, right, middle. So it sort of oscillates back and forth between these two with this middle sprite being every other frame. So left, middle, right, left, left, middle, right, middle, left, middle, right, middle, left, middle, that kind of thing. So that's what we're going to be implementing in this episode, as well as our gun bob. And so our gun bobs upwards every time we're in a left stride or a right stride, but if we're in the middle of our stride or standing or anything else, then it doesn't bob. So yeah. Why does it matter if we're oscillating or just looping? Well, the main reason it matters if we're oscillating is our gun bob is synced with our walk stride, like I said. So it goes up if we're in our left or right stride and down for our mid stride. And it actually looks pretty weird to have it up for 2 frames and down for 1, and then it just gets out of sync if we just do it timer based. So what we're going to do is not make another animated sprite. We're actually going to have a specific walking animation which animates a stride type enum. And so this is so that we can sync our gun bob easily, so we can know which part of the walking animation cycle we're in. Like, are we in the stride left or stride right or stride middle? And we can send this information over to our gun so it can know whether to bob up or down. And this is just going to be a private class to a player. Nobody else needs to know about it. And it's going to be replacing our current walk animated sprite with 3 static sprites and a stride type. So I think I'm going to start with implementing our stride type so we can see what this looks like. So I'll go into player.h to implement the stride type. We'll do it right below our motion type down here. Just another enum. No big deal. Same kind of first stride type. So what's our first stride type going to be? Let's make it stride middle. And then stride left. And then stride right. And finally, our last stride type. The next thing I want to do is kind of make a skeleton for our walking animation class. So I'll call it struct walking animation. And this is going to be kind of like our health class where it's implemented in another file, not player.cc, but player walking animation.cc. But for now, I'm just going to have it have a single stride getter. So I'm going to call it's going to return a stride type. And I'll call it stride. And it's going to be const. And for now, until I finish everything, I'm just going to have it return stride middle. I'll have it return stride left. How about that? Just to make it more interesting. The next thing I want to do is actually add it to our sprite tuple and our sprite state. So I'll just add it in here. So stride type and add it at the end because it's easier. So this will return a stride type. Let's call it stride type this time. And it'll just be get 3. One more thing we need to do now that we've added it to our sprite tuple is we need to add it to our initialized sprites so that we make sure that we hit every single case. Let's scroll down to initialize sprites. So yeah, this boost make tuple needs to be updated. So let's do another enum for each, and we'll call it stride type. And this will loop over stride type. And add stride type down to our boost make tuple call. So stride type, stride type. Looks like my parenthesis needs to be moved down here, and it should be happy. The next thing I'm going to do is actually fill in our initialized sprite, and this won't be a skeleton. We'll just fill it in because it's really simple, and it's just 3 cases, and we're just going to trade in this animated sprite like I said. So it's going to be a new sprite, and let's work out. It's no longer going to take k walk frames FPS or k num walk frames. Okay, so let's work out the different cases it could be in. So let's make a switch statement based on our sprite state dot stride type. So case number 1, our stride middle, we don't do anything. That was easy. Stride left is going to mean we need to increment tile x by 1. And stride right means we increment x by 2. So before, our animated sprite was handling all this calculation for us, but now that we are switching to a stride type, we need to actually fill this information in manually. But it's okay because we get to know when we are, at what point in the animation we're at. So case, I'll do default. So now I'm going to build and test this, and I would expect to see the walking animation just looks like, let's see, we have an error, so let me look at this. Oh yeah, so there's one more place where we need to use our walking animations.stride type. So let's do that here, down here in get sprite state. It's down below vertical facing. We also need to use a walking animation, our walking animation stride. So let's add a walking animation variable to our player class, and I'll just do it above our polar star. It's default constructed, so I'm not worried about anything there. So let's do walking animation dot stride, and that should fix that bug. So it was just saying this boost make tuple wasn't transforming into a sprite state. So let's build, and I would expect our walk frame to just be a left stride. So let's make sure that that's working. Because again, this walking animation dot stride is only implementing stride left. So I'm building, let's look. Yep, it looks like he's just striding left the whole time. Now let's actually implement our oscillation. So I'm just going to go over everything we need for our walking animation and then open up a new file to implement it. So the first thing we're going to need, and this one's obvious, is we're going to need to keep track of our stride. Well, actually, no, let's not keep track of stride. Let's keep track of our current index. And this is going to translate not exactly to stride, not one-to-one to stride, but it's okay. So let's call it size t or int current index. We're going to need a timer again. We're going to need to know which way in our oscillation we're going. Are we going forward or backwards? So I'm going to have a bool forward. And then we're also going to need to know the number of walk frames, but that's a constant that we can just move over into our CC file. So I'm going to declare a constructor and then define it inside of the new CC file, walking animation. Again, default constructed because we don't need it to take in any arguments. So I'll go into Solution Explorer and add new item. I'll call it player walking animation .cc, include player. And then I'll make sure to initialize all of these. Frame timer is going to get 1000 divided by k walk FPS, which we need to get from our player.cc file. And while I'm at it, I'll get k num walk frames. Let's initialize our current index to 1 or 0. And let's do forward to true. Let's also scope this into our player class so that everything's happy. Now that we have this initialized, let's add an update method to our walking animation. It doesn't need to take it in elapsed time because remember our timers are updated on their own. So I'll just call it void update, no arguments. Okay, let's start with the easy part. The easier part is if our frame is expired, we need to reset it, excuse me. Frame timer dot expired. Frame timer dot reset. Okay, so now what do we want to do? Well, now let's update our current index, which is really similar to our current frame, except our current index is going to translate over to a stride type, and we don't actually have frames of animation, so that's why I'm calling it a current index. So let's go down below frame timer.reset, and if we are moving forward, if our forward flag is true, then we want to increment our current index. If forward is false, then we want to decrement it. So let's do that. If forward else. So we'll do current index, plus current index, and then minus current index. The next thing we need to worry about is switching our forward if we've reached the end of our, so if we've reached the end of our number of walk frames, we need to switch which direction we're going. So if we're going forward, we need to check to see if our current index is at the end. So if current index is equal to k num walk frames minus 1, then we need to set forward equal to false. Equivalently, we could write this as forward is equal to not this. So current index not equal to k num walk frames minus 1. Next, we need to check when we're going backwards, and we've reached the end if we're going, so if current index is equal to 0, that means we've reached the end and we need to turn around. So we can set forward to be true. Equivalently, we could write this as forward is equal to current index greater than 0, or not equal to 0, whatever. Finally, we need to set our slide type, or determine our slide type based on the current index. And let's actually do that in our getter method. So I'll go into player.h, and instead of returning stride left, we will implement this in our CC file. So in our current update, our current index goes from 0, 1, 2, 1, 0, 1, 2, 1, 0. So the 1 frame is getting hit every other time. And we want that to correlate to our stride middle. So let's do a switch case and translate it. So switch based on our current index. If our current index is 0, let's make 0 stride left. So return stride left. If it's 1, we can return middle. And if it's 2, we can return stride right. Let's return stride middle as a default. Okay, so let's see if this works. And this is clearly not working. And I wonder what the... Okay. Yeah, I didn't remember to update it. That was silly. And also, while I'm here, this forward equals... This doesn't look right to me. So forward should be true if we have reached the end. So no, this should be equal 0. So if we've reached the end, and in this case the end is the beginning, because we're going backwards, so forward should be true when we've hit the end of that. Okay, and then also in player.cc in our update, let's make sure that we actually call walking animation.update. Otherwise it will never update. So let's hit F7 to build. And I'll run it so that we can see. So I think this looks right. I'm going to slow down time in our update. Our game.cc, we can slow down time just by dividing. This is a cool trick, actually. So if you're looking for a cool trick, watch. So in update, I can hit divide by 4, and it'll give me quarter time. And so I can just see what this looks like in slow motion. Woo! Yes, this looks perfect. Okay, now we can add the gun bob. So I'm gonna add this. I'm gonna fill out the logic inside of our player class when we're calling our gun. So we can just pass in a gun down method or gun up method. So let's do gun up, just like after our vertical facing or something. So let's work out this logic. So const. So our gun is going to be in its up state if we're walking, first of all, and second of all, if we are not in our middle state, or if we're in our left or right state. So I'm just going to write this like, okay, so let's figure out what our motion type is. And we've actually got this figured out down below. So I'm going to extract this into a function. Right here, we're determining our motion type. So I'm going to extract this into a private function because we need it in more than one place. So let's see, let's just call it motion type, and I'll do it right above on ground. And I'll call it motion type const, and implement it above here. And just move all this into here. Return our motion, return motion, and call it here. Okay, now that we can get our motion type, we can know if we're walking or not. So where are we? And draw. Here we go. So gun up is if we're walking, so motion type is walking. Then or we can do it this way. So we want to make sure our gun is up if we're walking and we're either stride left or stride right. Or another way of saying stride left, we are here, stride left or stride right. Another way of saying stride left or stride right is not stride middle, because remember there's 3 choices. So we can just say walking animation dot stride is not equal to. Okay. So now let's go into our polar star and make sure that we can take this gun up parameter and then just bump us up a couple of pixels, or just 1 pixel. So go to polar star.h. I'll just take a Boolean gun up to draw. And open CC. And then down here in draw, taking a gun up. So let's say if gun up, then y minus equals, because remember minus is up, 2 game units. And I think that should do it. So let's look at how this looks. And it'll be slow motion still, which will be cool. Sweet. Looks awesome. So one more thing I want to do while I'm here is reset our walk animation every time we start a new walk, I guess, so that he kind of jumps up every time I click, because sometimes it just slides. So let's make a reset method for our walking animation and then be done with this. So I'll go into player cc or player.h. Well, I didn't mean to do that. Oh, that's cool. And go into our walking animation and just make a reset method. So we can just reset everything to their defaults. And then go to player walking animation. Update. No, let's just define it down here. So forward, we'll just make it true. Current index equals 0, and frame timer dot reset. And then let's remember to call it in our start moving left and start moving right if we're not already moving. So start moving left. So if on ground and acceleration x is 0, then let's restart our player walking animation. I don't need the brackets because I'm just doing it all in one line. And the same logic applies to start moving right. So I'm going to build and run just so we can see it. It's not a big deal. This is really just kind of nitpicky, but I'm fine with being nitpicky. Yeah, that's what I want to see. That's what happens in the game. So okay, so let's speed things back up again and see it in real time, and then be done for reals. Okay. Sweet. The gun bobs. It looks beautiful. It bobs when he's looking up. So in the next video, I'm going to fix this problem where we're looking down and we should be looking horizontal. But yeah, this has been kind of a detail, but it's been bugging me, so I thought I'd fix it in this episode before we get into too much more and I get overwhelmed. So thanks for watching, guys. Happy developing.